Good evening, everyone. How are you? I'm fine. So, welcome to my channel. If you are new, welcome. So, today we'll be doing elastic and inelastic collision. So, this is the last chapter of momentum. Yeah. So, after this, we'll do a question paper. But now, let's get on it to work. So, we are now gonna do elastic collision. So, the first thing that you have to know in the elastic collision, basically, it is just the basic stuff. So, linear momentum is conserved. That's what you have to know. Okay, so today basically we'll be doing the kinetic energies. You'll be knowing and you'll be learning on how the different kinetic energies are they differs, or maybe when they are equal, what will be causing them to be like that and stuff. So elastic and inelastic collisions, it is when maybe the cars maybe there's an accident, or sometimes they don't maybe change the shape of the car if maybe there's an accident, something like that. We will be talking about the kinetic energies. Okay, so the linear momentum is conserved under elastic collision. And then number two, what you have to know, the colliding object remains separate. So remains separate, that's the point that you have to know. So the colliding objects remain separate, or don't change, that's what you have to know again. Okay, so those are one of the things that you have to know under elastic collision. So number three, the total kinetic energy is conserved. So kinetic energy, simply EK, is conserved. So this is the main thing that you have to know under elastic collision. Basically, you have to know what the kinetic energy is conserved in the elastic collision. You want? So don't confuse the two. And then what we do here, it basically means what the sum of the initial kinetic energy is equals to the sum of final kinetic energy. So before the collision and after the collision, so the kinetic energy is conserved, which means if this side it is 3600 joules, even this side it will be 3600 joules. If the two kinetic energies are the same, it means the collision is elastic. That's what you have to know. And then the last thing that you have to know, it is that the kinetic energy is not transformed to other forms of energy. What do I mean by saying other forms of energy? I will be talking about the heat or light or sound or whatever. So that's what you have to know under elastic collision. Elastic collision, the kinetic energy is conserved. That is the main thing that you have to know. Elastic collision, the two objects remain separate, or they are not changed. Elastic collision, the total kinetic energy initially is equals to the total kinetic energy after, or the total kinetic energy before the collision is equals to the total kinetic energy after the collision. Okay, so now let's check the inelastic collision. Okay, inelastic collision is, sorry guys, I have to buy another marker. This one is shy, but I will make a plan. Okay, so inelastic collision, it is basically the opposite. So the first thing, linear momentum is conserved. So from your linear momentum that we did last time, I sent the video, I uploaded the video last time. So number two that you have to know, and it is the first on the elastic collision, we said the colliding objects remain separate. So but right now we're gonna say the colliding objects do what? They join, or they do what? They change. So the colliding objects are now joined, or they change their shapes. You see? So this is the inelastic collision. So those are the basically the differences there. Number three, the main thing that you have to know, it is that the total kinetic energy is not conserved. So that is what you have to know. Under inelastic collision, the total kinetic energy is not conserved, but in the inelastic collision, the total kinetic energy is what? Is conserved. And then which means the sum of the initial kinetic energy is greater than the sum of the final kinetic energy. Yeah, one. So initially maybe it was 3600 joules, and then after it will be what, maybe 250 joules. I don't know, but you must know that this one must be greater than that one. So let's go. So the lastly, the kinetic energy is transformed to other forms of energy, like maybe heat, light, and stuff and stuff and stuff. So I'm gonna tell you the steps for solving on elastic and inelastic collision. So what you have to know, you have to know what you have to calculate the sum of the kinetic energies. So let me just do it here. So step number one, you calculate the sum of the sum of the sum of the kinetic energy before. So how do we calculate it? We simply do what? We simply say EKI is equals to 1 over 2 mv squared, but it is now what? M1 V1 initially, mv squared mv squared, but it is initially, then plus 1 over 2 m2 v2 squared initially, you see. And then step number 2, sum after. You calculate the sum of the kinetic energies of the objects after the collision, which means ukuthi lana it will be the same strategy, but m1 v1 f, and then after that you compare them. So if the kinetic energy is equals to the kinetic energy initially is equals to the kinetic energy after the collision, it means ukuthi it is elastic. So if the kinetic energy before the collision is not equals to the kinetic energy after the kinetic energy after, it means what it is what inelastic. So EK is equals to EK Fi elastic. EKI is not equals to EKF inelastic. So those are the things that you have to know basically about those things. Okay, so I will do the example when I do the question paper, because it is now the same as the linear momentum, because it is 1 over 2 mv squared, so it is basically the same. So I think everything will be now fine. So I'll do a question paper later on. So thank you very much, guys. I hope you enjoyed and learned. Okay, so yeah, this is how we do it. Elastic collision. So I wrote this one later on. So yeah, this is like that. Thank you, guys.